I'm just going to switch my video off. Then the video is a bit clearer. It's faster. So what's very important of tonight's exercise, it's all about transformer calculations. Now something in front of you, you'll see, it's a nameplate I gave you. But in the exam, they won't give you a nameplate. They'll give you some values. And from the values, you have to say, what is the impedance of this transformer? Right, guys, with this one, you guys see on the computer screen. Can you see that there is a nameplate of a transformer? They ask for you, what's the impedance? The impedance is given in percentage. Can you see that the impedance is 3.8%? Last week, I told you what is the impedance. Impedance is the voltage drop in percentage under full load conditions. When this transformer draws 278 amps in the secondary side, the voltage will drop by how many percent? 3.8%. So that's okay. You guys understand that? Right? Now, what is the voltage after 415 when it dropped? So what you do, you take 3.8% off, and the voltage which is left is 398 volts. So they can ask you, if the impedance was 5%, what is the voltage? The answer is 380, if it was 400. So if I say to you, the voltage is 415 volts, and it's fully loaded, and the impedance is 3.8%, do you agree that the voltage will drop by 3.8%? Because look, on the computer screen, they gave me impedance. But otherwise, I'll give it in words for you. Now let's try again in words. A three-phase transformer is given. The supply load voltage and secondary voltage is 415 volts. When it draws 278 amps, and with the impedance of 3.8%, what will be the load voltage now be? Can you see that you subtract the 8.38% or 3.8%, and you get 398? Guys, I don't know how good your maths is. I don't know how you operate with your calculator, but please try to deduct 3.8% of 415 volts. See what you guys get. Well done. Great, you guys. Right, I'm just going to open my script so I can see what you guys write. Cool. So very important. The examiner will ask you, bless you, the examiner will ask you, what is the voltage after or when it's fully loaded? So what you then do, you take the impedance and you minus the percentage from the original voltage, secondary side. Is that clear enough to everyone? So guys, when this transformer is fully loaded, this transformer will now draw on 398 volts. Now I ask you, what is the MVA rating of this transformer? In other words, when the transformer is fully loaded and there's a dead short, I'm going to say that again. The transformer is fully loaded and there's a dead short. What will happen with the kVA? Currently, it's a 200 kVA transformer. See there? Ah, bugger. What does training wants? Maris, hello? Yeah. Beg your pardon? Yes, Elno. Yes, Elno. For the theory class online. Yes, Elnor, I just sent it to you. Okay, Elnor, what is your email address? Give it to me again. What is it, Elnor? Elnor? What is your email address? EN? Yes? Hang on. Is it ELNO2590? Okay, I'm sending it again. All this was sent out last week, Sunday, to all of you guys, or Monday. Have a look if you got it. You got it? Okay, go. Okay, bye. So guys, what I want to ask, this transformer, when it's fully loaded, the maximum kVA is 200 kVA, but under short circuit conditions, your kVA is going to go very high. So what is the fault level of the transformer? And fault level is the same as your MVA. For all what you do, you take your kVA, and there's a formula, sorry, that's a formula to work out the impedance. It's just an example. To work out the MVA, you take your kVA, and you divide it by what? By the percentage? Impedance. Yeah. So I'm going to say that again. To work out the fault level of the transformer, in other words, the new kVA, you take the kVA and divide it by impedance. Now, guys, you don't need to worry about the formula. The formula is given to you on the formula sheet. MVA is your megavolt amps. It's just another term they use to call it your fault rating. Right. So, guys, there is the formula. Godwin, I need to talk to you, mate. Godwin, you're on mute, but I'll talk to you smoker time, okay? Smoker time, I'll talk to you. Okay. Right, guys, please take note. There is the formula. The formula says impedance is your S rating divided by S fault. Can you see that? Now, guys, I took that formula, and all what I did was I transposed it. Your fault, your S fault, your kVA or your MVA will be your kVA divided by impedance. Now, firstly, your S rating, that is your S rating. Your impedance is your impedance. Your S fault is your MVA rating. It's just another way how the examiner will give it to you. It is just transposed. So there, the percentage is there. There's my impedance, which is a percentage. So guys, it's a 200 kVA transformer. You all agree with that? What is the impedance? You all agree it's 0.38 or 3.8%. You do your calculation, and there's your MVA rating. So all what you do, you take your kVA and divide it by the impedance. But don't divide it by 3.8, divide it by 0.038, because it's 3.8% divided by 100. You guys with me? So in the exam, if this transformer was a 500 kVA transformer and the impedance was 5%, then all what you need to do is to take 500,000 divided by 0.05. Happy? Cool? We must learn to do what they say. Now, in my book, you'll see there's a couple of examples and a couple of ways how to do it. Have a look. There's questions on this. But I really want you guys to practice this, because you're going to get this in the exam. The next one, what's meant by this prospective short circuit current? Now, guys, as you can see here, do you all agree that this transformer will draw 278 amps? Happy? When this transformer has got a dead short, what's going to happen with that amps? It's going to go hell of a high. How do you work that out? Very simple. You take that current and you divide it by the impedance. So take your calculator and say 278 divided by 0.038. 0.038. How much you get? Right, so under short circuit conditions, your fault current will be 7,300 amps. Now, gentlemen, ladies online, that 3 questions has been asked in your exam previously. What is the drop in voltage? What is the MVA fault rating? And C, what is the prospective short circuit current? Make sense? But guys, if you don't know how to work out the current, if it was not given, you can use the formula S divided by root 3V. But all what I do is I add the impedance, and that answer will give me exactly the same answer. It's just another way if current was not given. So kVA divided by root 3 voltage is the same as amps. And amps divided by the impedance will still give me the same answer. So guys, this part where I circle now is an alternative formula how to work out 278 amps. All right. Now guys, that formula is also on your formula sheet. Now what I'm going to do with my next slide, I'm going to give you time to do it. I want you guys to try it, even if you do it with your calculator without doing any calculation on paper. I want to know what is the impedance. In other words, what is the impedance percentage on this formula sheet, this nameplate? I want to know what's my MVA rating. I want to know what my short circuit current is, and I want to know the cooling method. I'll give you a hint. The impedance is there, and how many percent? 4%. You all agree that? Is that 4% impedance? Now, just a matter of interest while we are there, what is the secondary voltage? The no-load voltage, 400 and? Now, work for me out. If you say there's a drop of 4%, what is the voltage you'll measure at full load? So what is 415 minus 4%? Try that with your calculator. Oh, that's an option way. That is an option way. But the answer will be a little bit less than 415. 398? Right, guys? 415 minus 415 times 4%. Give me 398. Right. Well done. You guys are typing right answers in. Right, what? 415 is your no load voltage. If you take 4% off, that becomes full load. That is your full load voltage. That's your no load voltage. So there will be a drop in 4%. And that's why that impedance is there. And that's why we're practicing that. Right, what's your MVA rating? That's easy. I'll give you a hint. Obviously, that's what we just did. S divided by impedance. How much you guys get? A? S, there it is. S is your kVA. Is it 100 kVA? Yep. It's 100 kVA. So 100,000 volt amps divided by 0.04. 100,000, look, kVA. Right, so 2,500 kVA, so that's my formula. I transpose it to get that. No, 0.038. So you say 3.8 divided by 100. This is 4 divided by 100. Right, what is this answer, guys? I saw some guys writing good answers down. 2.5 million or 2,500 kVA. But a fault level is always given an MVA. So the answer is 2.5 MVA. So guys, Ismail, Jared, you guys, Vijay, Jonathan, Panama, you guys who got these answers, just remember your MVA is always your fault level. You give it an MVA, not in kVA. Okay with that? Right, so you guys know how to get that in your calculators. If you get a long answer, press ENG on your calculator. And 10 to the power of 6 becomes million. 3 is kilo. So type it in 100,000 divided by 0.04 and see what your calculator said. Your calculator will say 250,000,000,000. You know what I can do with a million or two? Right. If it doesn't simplify, press ENG on your calculators. And that ENG will then say 10 to the power of 6. That's MVA. Okay, that's kilo. Press ENG again. Okay. Okay, equals. Okay, let me have a look quickly. So did you say 100,000 divided by? Okay. Now it's divided by. Right, you see there's your answer. Press ENG. Power 6, 2.5 MVA. Press ENG again. Power 3, that's kilo. That will take you. All right, so if you press in 100,000 divided by 0.04, you get 2.5 million, 250,000,000. Press ENG, and it will say 2.5 to the power of 6. 6 means million. There's your answer. If they want it in kilo, press that ENG again, and it will say 10 to the power of 3. Okay?
What's HV and LV?
High voltage, primary side. LV, low voltage side, secondary side. All right? Okay, guys, what is my prospective short circuit current?
So you take it from the LV.
Always secondary side. We're always worried about secondary side. Primary side, we don't get shit.
Because there's no amps.
There's hardly amps because you. Right. So, guys, what is my normal current? 139.1. 139.1 divided by 0.04, 3.45, 3.46, somewhere there. Right, well done, guys. The guys are right to answer. Vijay, you guys. Clayton, can I just ask, remember, your prospective short circuit current is always in KA, kiloamps. Okay with that? It's just something different you need to learn. Now, guys, if the current of 139.1 was not given, you can work it out. S divided by root 3V. And then 100,000 divided by root 3 for 15 will give you 139.1 amps divided by 0.04, and then you get an answer of 34, which is roughly the same. Is that clear to everybody? Now, guys, if you want to bargain on 3 marks, that is the 3-mark question. Now, I'm going to take a guess. There's quite a few guys online. I'm just going to put my mouse over someone. Jesse, are you online? Clayton, to answer your question, it depends what the examiner asks. If they want it in KA or do they want it in amps. If it's in kiloamps and you write down 3,450, it's wrong. I'm going to say that again. I'm just repeating a question they asked online. If they asked your prospective short circuit current in this one in kiloamps, you cannot say 3,482. You have to say 3.4. If they ask you what is the short circuit current in amps, then you can't say 3.45. You have to say 3,450. Make sense? Do what they ask. Right, Jesse. Right, so Clayton, just to answer your question again, answer the question they want. Do they want an amps or in kiloamps, your short circuit current? Secondly, do they want the MVA, your fault level, in million volt amps, MVA, or in kVA? But normally, your fault level will be in MVA, and your kVA, your short circuit current will be in kiloamps. That is the normal terms in which they answer it. Right, Jesse is most probably switched on and went for a smoke. Let's try someone else. Clayton, can you see on the computer how do you keep this transformer cool? Could you guys remember this last week? The oil, natural, air, natural. Inside, outside. Yes, well done, Clayton. So, oil, natural, inside. Air, natural, outside. Inside, outside. Gentlemen, 1 mark. Will that be all right? I hope so. Remember, O stands for oil, A stands for air, N for natural, F for forced. Is that all right? Cool bananas. Guys, there, 5 marks. Easy in your exam. Read your questions well. Guys, all in one capture. Now, what I'm going to do now is I'm going to lead you into the next phase of calculations. Some of you guys will say, my bugger, I hate this. Some of you guys will say, oh shit, this is easy. So, questions I would like to ask. Firstly, what is that connection called? Star or delta? Star. And gentlemen, ladies, my book has got all the slides in your book. You just have to follow. Right. So, firstly, what do we call that voltage? Line or phase voltage? Between line 1 and line 2. Line 2 and line 3. Line 1 and line 3. V lines. Now, think about 3-phase. How much volts will you measure there? 400. Yes. Guys, the voltage between line and neutral, line and neutral, line and neutral. How much volt is that if you physically measure it? 230. Is that line voltage or phase voltage? Phase. So guys, that is very, very important when you do calculations on transformers. Reason? Some parts, depends what formula you use. We use line voltages. Some part we use phase voltages. It's all up to you what you want to use. So I'm setting the scene. Are you guys okay? Happy with that? Right. Now guys, do you agree that V line, the 400, it will be 230 times root 3, or V phase times root 3. Now V line will be V phase will be V line divided by root 3. Now that formula you don't need to learn. It is on a formula sheet. The current flows in the line is called what current? Line current or coil current or phase current? Line current. What do you call the current through the coil? Phase current. The current through the coil? Phase current. The current in the line? Line current. Did you know that in a star connection, I line equals I phase, or I phase equals I line? See there? They are the same because they keep on flowing in series through the coils. Do I need to remember this? No, because you look at your formula sheet, there is the formulas there for you. It says there that I line equals I phase, and it also says there that your V line is V phase, your V phase is V line divided by root 3. Because we normally say the current through one coil is called phase current. Because look at the voltage. Yes, so the voltage across here is 230, right? And the voltage between the lines is 400. It depends what calculation you do, but you know in star, the current stays the same. The voltage just changes. So can I confirm, in a star connection, the currents stay the same? Happy? Right, so now, I'm going to ask you to remember the two formulas which I put down there. Now, work out the S, the kVA of the transformer. It's V line, I line. So you must know what the line voltage is. You must know what the line current is. All right? If you decide to use the coil voltage system, S equals coil voltage times coil current. But how many of the coils are there? 3. And that's why you have to multiply it with 3. And both of that answers will be the same. All right? And we're going to practice it. Now, guys, that's all formulas you need to know, except of one more. Are you okay with that? Now, guys, tell me, Is all that formulas on your formula sheet? Are they? Of course. That's why transformers are so easy. But you guys don't want to practice it. And guess what? For the apprentices, December's coming. Those are an old qual.
October, isn't it?
Well, we try to get finished by October. But December, ka-ching, the curtain drops. But don't give up. Practice this. Practice this. Remember where the formulas come from. And the reason I keep that formula sheet always with you, because in the exam, guess what? The formula sheet will be given. So my front page of my book has got the formulas in. Just learn to use it. And the only way to learn to use it is not just to come here once a week, but it's to do something from now till next week. Now, I must admit, quite a few trainees would text me, is this right? Why do I get this wrong? Why is this wrong? Why is this right? And I will answer you some answers. Just communicate with me. But if you're not communicating, then I accept you guys are going, oh, well, you guys don't have problems. Hey, Joseph? Right, let's look at delta. Do you know that the delta connection is not the same as a star? Now, in a star, what is the same? Current. What is the same in a delta connection? Voltage. Right, let's have a look. V line, across the coil, V phase. V line equals V phase. V line equals V phase. I phase equals I line. Try again. V phase equals V line, and V line equals V phase. You happy with that? Voltage stays the same. Do you all agree with me? Now let's rewind quickly. What was the same in a star connection? Current. What is the same in a delta connection? The voltages. You guys okay with that? Now what changes? Right, guys? Current in the line is called line current. The current in the coil is called phase current. Do you think they're the same? I'll give you a hint. Do they split up? Right. And in electrical terms, we never say split. We use root 3. That's it. Current splits, root 3. If voltage splits, root 3. 400 divided by root 3. Not 400 divided by 2, or 400 divided by 3. It's the root 3 of. Why? It's 3 phase, 120 degrees out of phase. It's a formula to prove it. We're not there where we have to prove it. You would have learned it. Or what we need to know, that V line is not the same as V phase. Try again. I line is not the same as I phase in a delta connection. Now, if the currents gets together, we call it I line again. But here comes the cool part. Formula is given. On the formula sheet, which is delta. Now in delta, V line equals V phase, or V phase equals V line. But the currents, I phase is I line divided by root 3, and vice versa. But now I'm going to ask you a multi-million-dollar question. When you look at the I line, I phase calculation, which one is the biggest, line or phase? Line. When it comes to voltages, what is the biggest when it comes to delta? I'll give you a hint. Look there. They're the same. Right. Why is this important? Because when we're going to use that same formulas over there, you must know if you're going to use line voltages or if you're going to use phase voltages. Now, who determines which voltages and current you want to use? You, because you must determine which formula you want to use. Now, gentlemen, what I could have done, and ladies, I could have just told you, do everything the line value way. You can. But sometimes they give you a coil current, then you can use the coil voltage method. But just remember, how many coils are there? 3. That's why we multiplied with 3. Now next week, when we're going to do some revision on supply systems, you'll see that I'm going to use this formula again to work out the wattage of a delta connected load. Where I gave you that big nameplate where I told you guys voltage is 400, the current in the red, the current in the white, and the current in the blue. Are they the same or not? Voila. Right. Let's recap. And then we're going to do it again. Right, guys? This transformer, is it single phase or three phase? Yes. Right. What does kVA stand for? Anybody know? Volt amps. What is that? How's the transformer connected? DY. Delta star. Did I mention last week there's 3 or 4 different connections? Delta star is one. What's the other 3? Star and? If I give you some connections, will you figure out which one is which one? You will get that in exam. They ask that in every exam. It's 1 mark.
Did they give you a picture like that?
No. The one with the windings, which we did last week. That is just my nameplate to show you realistically. And it's incredible. People actually start remembering what's on nameplates, and then it's easier to understand. Right, guys? That is delta. Do you all agree? Right, have a look. You all agree it's a 200 kVA transformer. Right, guys? Look at this. The high voltage side, is that the primary side or secondary side? It's a step down transformer. So the primary is how many volts? 11,000. Right. Have a guess. If there's 11,000 volts there, what is the current in the primary side? What is it written there? So there's 10.6 amps. Okay with that? Right, guys, let's try again. 10.6 there, 10.6 there, 10.6 there. The current in the coil is divided by √3. Yeah. Right? Let's go to the primary side. I try again, secondary side. What is the voltage between line 1 and line 2? Right. Somebody asked me this question earlier. Is that no load voltage or full load voltage? No load. That means there's no load connected. Now, we always use no load voltage in calculations. All right? But do you know that that voltage will drop by 3.8% when it's fully loaded? But that's just for the paperwork. We're not going to worry about it. We always just use 415. All right? Now, look at this one. What is that 278? That is the current in the secondary. Now, guys, do you agree it's 278, 278, 278, 278, 278, 278? Happy? Now, guys, here comes the smart part. In the exam, one of them will not be given, and you have to work it out. That's transformer calculation. You must learn to work out the ones which is not there. And guess what? There's a formula for all of that. Now, before I want to do a formula, do you agree this is voltage current primary side, voltage current secondary side? Is there a formula which says V primary, V secondary, N primary, N secondary, I secondary, I primary? Yeah. Right. That is the currents and voltages. But there's one big trick around all that. And that is what I want to show you later when we're going to do this. But before I carry on, yes?
How do you tell the delta star or star?
The delta star is given. This one is given, but otherwise they will tell us in writing. We'll do that shortly. So guys, if the line voltage was 415, what's the coil voltage? The voltage across the coil?
230.
Is it a little bit more? 415 divided by √3?
Oh, yeah.
240. You all see that? So guys, now I'm going to give you a little sneak view how they're going to catch you in exam. What's a ratio of this transformer? How do you work out the ratio of this transformer? Is it a 10:1, a 20:1, a 50:1? Right. Its voltage is given. So we got 11,000. Right. What is that side? 415. Right. I'm going to prove to you why it's wrong. And this must be a hard lesson to all of you. Right. If you want to make one of them, you take one of them, you divide by 415, you divide the other side by 415. Is that right? But gentlemen, that's wrong. Because when you work out ratio, I'm going to say this to you guys once and I don't want to send it again. It's coil to coil. Ratios is coil to coil. So what is the coil voltage in the primary side? 11,000. What is the coil voltage in the secondary side? Yes, well done, Graham. So the ratio actually is 11,000 is to 240. And that will give me a ratio. That is the ratio of the transformer. Because it's the ratio, 1:1. The one coil to one coil. One coil current to the other side coil current. The primary turns versus secondary turns. Now, if you look at that, can you see there's one coil to two coils? If you look at it, we never work out the ratio. The ratio is coil to coil, phase to phase. Happy with that? Right, it's just as well we learned that you have to drive on the left-hand side of the road and you don't sleep when you drive. When it comes to transformers, ratio is coil to coil. Is that clear to everyone? Right, now look how simple this is. Let's see what the current ratio is. Do you all agree it's 10.6 is to 278? Yes or no? Say no. Do you agree it's not line to line, it's coil to coil? Right, now, do you all agree that in the secondary side, and by the way, if you do your calculation, your ratio is not that. You all agree that your coil current is 278, 278, 278? Right? What is your coil current in this primary side? 10.6 divided by root 3? You guys agree with that? And that gives me 6.13. And guess what? Look here. The ratio is the same, but other way around. So that tells me voltage drop, current increase. Is that current inverse proportional to voltage? I'm going to ask again. V primary, V secondary. Turns primary, turns secondary. Current secondary to current primary. You see, current is inverse. So if the transformer has got a ratio, when we buy a transformer and you go to the transformer company, do you going to rate the transformer, can I have a step down current transformer? Or are you going to say, I want a voltage step down transformer? How do you buy it? You buy it on voltage. You buy it always on voltage. The ratio is not 1:45.8. The ratio is 45.8 is to 1. You always rate it to voltage. Got it? If I say to you the voltage is going to drop of 45.8 is to 1, then the current is the opposite. Current will increase 1:45.8. It's a step down transformer. You always rate it on voltage. Always on voltage. So this transformer will drop the voltage from 11,000 to 415. But to work out the ratio, it's coil to coil. This ratio of this transformer is 45.8 is to 1. Yes.
So will it always be like the voltage and then the current, and they'll always be swapped around?
Correct. So if I give you a transformer and it's just 20 to 1, voltage 20, voltage 1. Current is 1:20. Happy with that? Now, gentlemen, ladies on board, there is all what you need to apply. Now, we're going to practice a couple of them. And I hope you guys will have your calculators ready. And I want you guys to support me in this. Now, to confirm, kVA is equal to root 3 VI. Happy? That is just a summary of all your voltages. It's in the book. Right. You know the difference between the two, line and phase. Is that the different formulas? What does phase represent? Coil or line? Coil. So which one of the two is single phase? The top one or the bottom one? Top one is single phase. You agree? Yeah. How many coils are there if you want to use the coil values? 3 of them. But otherwise there could be only one. Right, you all agree that line values is always in there and phase values is always in there. Not too bad, eh? It's the same phase values, also coil values. It's exactly the same. Right, guys? The next one I'd like to share is if it's a 3-phase one, If it's a three-phase one, you always remember to use the √3. Line voltage, line current. They will always give you something on your nameplate, if they give you a nameplate. Now look at this one. If I give you a ratio, V primary, V secondary, or V secondary, V primary, turn secondary, turn primary, or current primary or secondary, can you see that the current is inverse proportional? Now guys, $1 million question. This formula, that ratio, is on your formula sheet. Now here comes the last thing I'd like to show. That turns over here is always coil values, regardless what you do. So when you're going to work at a calculator and you use ratios, 1:5 or 20:1, or you use VS, VP, ISP, and all that formulas, it's always coil values. And that's where people stuff it up. They use line instead of phase. Now, all this baloney I'm told you now, we're going to apply in a calculation. The part I brought up now is a bit of a revision of the work we did earlier last week and this week. Do you agree that this 4 configurations is what we did last week? You got to agree with that? Right, guys? You also agree that that formulas over there is the ones we looked at earlier when we looked at a transformer. And I said to you, what is the MVA of the transformer? What is the KVA of the transformer? And also, how do you keep it cool? Okay? Now let's take all those lovely things and we toss it into a question. The sad part is, in the exam, they will not give you that picture. They will give you the wording. All right? It says, once upon a time, long, long ago, there was a 250 kVA transformer. The transformer had a ratio 287:1. The primary voltage is 66,000 volts. That's it. That's enough information to do everything you require. Now, gentlemen, ladies, this example is called X because trainees told me I had this example in the exam and that was the same values. All what I did was I made up my own story and I gave you a drawing. Now, the question is, what is my secondary phase what? Voltage. Now, does anybody know where is the phase voltage? Is it between line 1 and line 2, or is it between line 1 and neutral? Line 1 and? Phase, look, phase, not line voltage, but phase voltage. You all agree there? Line 1 and neutral. If I ask you what is line voltage, it will be between line 1 and line 2. You all agree with that? Now, let's twinkle toes and decide what formula we're going to use. Now, before we do any formula, do I have the primary voltage? Do I have the secondary voltage? No. Do we have the primary turns? Do I have the secondary turns? I can use a ratio because I've got the turns, there's 1 voltage outstanding. Now, Joseph, when you look at that formula, is it coil values or line values? I just wanted to ask if you listen to what I said about 20 times. If I give you that ratios, is it coil values or line values? Can anybody help me? Coil values or phase values? Right. Now here comes the part. When you write it down, can you see Marius suggest to put the unknown one in the top left? Do you all agree I need to work out this secondary voltage? Where's my mouse? There we are. I need to work out the secondary voltage. You see that? Now, all what you need to do is take this voltage and push it up. See the formula? There's a bit of a transpositioning. I know a lot of you guys struggle. So when I multiply this with VP, it cancels out. And I must multiply that with VP. And there's my transpositioning. So the way I want to show you is quick. Is you put your unknown one at the top. Is this primary voltage given? Look, it's a given. Bless you. is the coil turns given? So I can use that formula. So look what I do. I push that up. There it is. And there's my formula. Now all I'm going to do is put values in. Now anybody help me. What is the secondary turns? 1. Correct. What is my primary voltage? Remember, coil voltage. Coil voltage. Well, a delta line and coil is the same. Remember that rule? Right. And what's my secondary turns? 27. Type that in your calculators. What do you guys get? 229. It's about 230. Well done, Clayton. Well done, Godwin. Jonathan, well done. There's a lot of guys typing the right answers in. So can I confirm, guys, that ratio is for free. You got it on the nameplate, on the formula sheet. Put the unknown one at the top, transpose, and put the values in. Gentlemen, there's no other way how to do it. That is the only formula way you can do it. There is no other formula to work it out. Learn to do that. Not once, not twice, a lot of times. Because that question's been asked a lot of times. Now, to piggyback on top of this one, if I know that that now is 230, the next question is, what is my line voltage? In other words, between line 1 and line 2. Have a guess. If that's 230, how much is that? You can guess the answer. What's 230 times root 3? 400. Right, let's have a look. V line is root 3 times V phase. Where did I got that from? Isn't that from that formula sheet? Yep. What is root 3? If you type it in your calculator, 1.73. Multiply with that 230. There's your answer. Now, guys, that 2 marks in the exam. Come on, tell you the thing. They're not going to ask you the primary, the coil current. They're going to ask you the line current straight away. Do you agree that you have to do this and this to get 400? 2 marks. You're going to get it. I know you guys are going to get it. That could be the only 2 marks they give you on transformer calculations. The only thing now left is to work out the amps here and the amps here. And that's just as easy. So gentlemen, ladies, we are now halfway with transformer calculations. The other half is to work out the amps. So to work out the voltage, I must use a ratio in this case, and then I can use the root 3 formula to get the line voltage. You guys okay with that? Any questions? Right, Godwin, you get 398.31. Guys, what you get in your calculator, you type in the exam. Don't round it off. I just round it off to give you a bit of an idea what the answer could be. Okay with that? Lovely. So that is the first part. The second part, do you all agree that I just worked out this? You all happy? The question now is, what is my primary line current? I want to know what that current is there. I'll give you a hint. Is there any currents given anywhere? There's no currents in the question. So there's only one formula. There we are. Is kVA given? Is voltage given? What do you have to do with that formula? Transpose. Do you all agree that I is S divided by root 3V? Come on, guys, you've seen this formula so many times, over and over and over. We've done this way back in week 1. We did it in week 2. We did it with motors. We're now doing it with transformers. Now, the question is, what is my S? Anyone? 250 or 250,000?
250,000.
Yes, well done. What is root 3? 1.73. Right, guys? And what is VL? What is my line voltage in my primary side? 66,000. Now type that into your calculators and see what you guys get. And I'm asking you guys, please, because sometimes we type in the wrong values and we don't know how the root works on your formula sheet, on your calculator. Those who's got the calculator with the blue oval, just remember when you say root 3, press the space bar. You should get an answer of 2.19. If you don't, you didn't use brackets. If you don't, you didn't move your root. See if you guys get it. Got it? So just say 250,000. By bracket open. You write there root 3. Right. Yep. Yeah. Times 66,000. Alright. 2.1. So brackets will help, eh? Cool. Right. Next question. Now that we know what the line current is on the other side, can I work out the line current in the secondary side? Anyone going to try that? Can I give you a hint? Use the same formula. And I'll transpose it, and now you type it in and see what you guys get. I'll give you 2 minutes. How many you guys get? You can. I'm not probably going to do it now as another alternative. So long you get 360.8, I don't care how you do it.
Can you use the change ratio?
Godwin? 360. Connor? Sorry?
Can you use the change ratio?
You can use a turn ratio, but I'm going to tell you what the risk is. You can't use 2.19. What are you going to use?
2.186.
As I told you, you're going to use the current of 2.19. You divide it by root 3. You must get coil current. And once you got the coil current, then you know it's 287 times bigger. I think, no, I didn't do it. I'll show you guys the alternative method. Now, I'm going to ask again. The reason I did this one, it's very simple. But if you want to use IS over IP equals NP over NS, then remember, when you use the I values, you cannot use that. You must divide it by root 3. You must know the coil current, because one coil current versus other coil current. Do me a favor. Take 360 divided by 287.
1.25.
Okay, 1.25. Multiply that with root 3. There we are. See there? 2.1. So, if you know what the current in the coil here is, which is 360, you know that this side is 287 times less. Remember? It goes up the current, the voltage goes down. That is the trick about this. And that's why I try to stay with this. Then I know the risk to make a mistake is way less. Make sense? But I'll leave it to you. Right. Now here comes the next exercise. Question XX. I want to know what is my secondary phase voltage. And I would like to know, let me just see. Right, there we are. I'm going to give you 4 minutes. So you guys can do that for me. It's the same question, different ratios, different voltages. Tell me what is the coil current. I'm going to give you 4 minutes. I will quiet now. Checking with the guys online.
So 230 and 400. That formula's not even on the formula sheet.
Sorry?
That formula's not on the formula sheet.
It is?
I can't find it.
N1 over N2 equals V1 over V2.
That's right. It's N1 into V1, V2. Right, guys, there we are. You all got 230 volts? The guys online, you guys are hot, mate. You guys are hitting it on the nail. And what about the other side? 400. Yeah. So, guys, if you get 398.6, put it down. Put down what you get on your calculator. It will be that window of tolerance in the exam. Okay with that? Now, guys, those who got my book, all the examples is in the book, and the answers, and exactly how I did it. Right. Are you okay with that? For the guys online, I ask them now to do the same question, but do the currents. Are you okay with that? Right, let's try the currents. There's the same question. In this case, I want to know what the currents are. So you guys can do it. I don't care how you do it. The reason I say I don't care is actually I do care. But I want you to do it the way you feel the most comfortable with. And I'll recommend this formula way. Because your possibility to make a mistake is way less. Yes. Okay. Firstly, which are the two you're going to use? You can't use all three. Okay, cool. So you can either have the one on top or the two on the top. Whether you primary or secondary, doesn't matter what you call it. The ones could be primary, and the twos could be secondary. You determine. Right. Okay, remember to right. I'll do it over here. Yeah. Right. You agree that G1 over V2 equals N1 over N2. Let's take it in words. Primary.
Doesn't matter if it's the other way around.
Correct, doesn't matter. So long the P's at the top when it comes to 2 and 5. Do you agree with current? I is over I2 is the opposite of it. Okay, but we're not going to worry about that. Now, you always put the unknown one at the top. So I'm going to put V secondary on the top. So I will put V primary at the bottom, then secondary, return primary, correct? See the rest of SP, SP. Okay. Okay, you can write it anyway.
What is it, the unknown, the one that we're trying to solve?
The unknown one I want to solve, I'll always put it at the top. It's just an easy way to do it. I'm going to show you a very quick trick without thinking. Right, second step, second step. Okay, because you have to get rid of VP, put it at the top. Just get rid of it by pushing it up. That is actually a naughty way to teach you. The right way is to multiply the one side, that cancel out, and multiply the other. that is the right term. But for you, because you don't want to learn this stuff off by heart your way, that's why you've got to take that and pick it up. And what's left? DS by itself. So that you simply volt term, primary term, and we voltage. And you just put your value in. Does that help?
Yeah.
Try that, practice it. So guys, what is the current you guys got? Now, I know there's no other way to work out the first current. The first one you have to do this way. I get 39.4. The guys online, well done. You guys doing fantastic. I see good values. Right, I'm just going to spot on one guy. Connor, well done, mate. Excellent. There's way more of you guys. You guys doing great. Now, what is the secondary one? Now, guys, you can use a ratio. I don't like it because we tend to make more mistakes. So I use the same formula, transpose it, and put the values in, and I get 1082.
I did it the ratio way and I got 1082.
Yep.
And then 1086 for the ratio. It's 4 different.
Right. All good, Connor. Right, so what I want to share here, did you guys got the same value? Now, can I confirm this 10,082, is that the current all the way where my mouse is going?
Oh, no.
So I line equals I phase equals I phase equals I line. You all agree? Do yourself a favor. Take your calculators and say 1,082. Divide that by 47.83, which is a ratio. How much you get? 22.6. So now you know the coil voltage, current. Now multiply that with root 3, so you get close to 39.
Yeah, then you get 1086.
Close. They're rounding off. It's around about 39. That's right. So guys, why do you think my answers differ from yours? Come I tell you why. You guys didn't use 400, you used 398. So that's why your answers will be a little bit different. But that's okay. We're all okay because they will accept a tolerance in this answer. So long you get about 1080-ish, 79, 85, that's fine. Okay with that? Cool. Sorry, you guys happy with that one? Now guys, the sad news is, this is all they can ask you transformers. Voltage primary, voltage secondary. The worst cases, if they don't give you the kVA, but then they have to give you the current and the voltage. Now do me a favor now. Take your calculators and type in the following. I'm going to go to the primary side. Type in root 3. So take your calculators, say root 3 times 11,000 times 39.4. You should get about 750.
Yeah.
Let's go to the secondary side. Root 3 times 400 times 1082. Very close, 750. Ah, can you see it balance out? It will always balance out. So root 3 VI, look there, all I did, I said to you guys, root 3 times 11,000 times 39.4, give me 750,000. This side, we take root 3 times 400 times 1082, give me 750,000. See that? Now guys, this question, a trainee got, but I think he maybe made a mistake. That's all right, I don't care. All I want you to ask now, I want you to take the same question, and I'm going to give you 8 minutes or 6 minutes. 7 minutes is enough. I want you to work at the two voltages, and I want you to work at both currents as well. So I want you to work at the voltage in the secondary phase, the voltage in the secondary line by using the ratio. And then once you're done, I want you to work at the current in this one and the current in that one. I'll start off by that. Yep. Go for that, guys. 4 questions.
So, I put the voltage on. So up to the current one. And then
Okay.
I got the volt up to
Okay. Before you do, why do you want to look at the primary one if you don't have the second one? Can you see that? On the previous question, we had the primary one, we didn't have the second one. So you have to put the second one. So right there, IS, IB. IB equals turns primary B. Again, how are we going to put that formula there? So why we put that one there? Right. So this is the coil. What does the coil then have? The same ones, I mean, you know what that is, that is just an odd question. There it is. It's the same question. There is 287, so it's the same question to that I can put it up. 287. That's primary. So you want to know what the primary is? 287 times. So what's your primary current? Remember, it's not the primary current, it's the line. It's the primary current in the soil. So right there, 1.27 equals. Okay, second term is 1. Hang on. 1 equals. Yeah. 360. So remember, when you use this value, make a circle and show 15 12 values. And that is what people do to show. They use the wrong primary current. If I give you, I give you delta, you must use this, not that. This is fine line, followed by that. That is correct. That's why it's we have to take it because fine lines. That one. Now that same question is as well. Remember, it's just a calculation. It doesn't have to be a reality. Right. Like in the first question. Same question. Always there was the question. Instead of having one with 4 questions, I just put them all in. So this question 57 is the same. Yeah, perfect. Now do the columns. Remember, right, Connor, you're on the dot with the voltage, mate. 406.92. Looks good to me. Jonathan, yep, you guys doing great. Well done. So guys, those who got my book, you'll be able to see how I did that as part of the questions. Look at the examples, look at the question. This is the same as question 57 under Transformers workbook. Well guys, remember that book is not toilet paper. Did you all got the same what I just put on the board? Now guys, you guys will say, hey, I don't use 692 volts. But remember, this is just an example. It's the idea how to work it out.
It's just because the first one was 400.
Yes. So that you worked out over here is the coil voltage. So they want to know what the line voltage is. So don't let this voltages confuse you. All right? Now, did you try the currents? Right, I'm going to go to the currents now. Now that we know the voltages, we now need to go do the currents. And primary current and secondary line current. Now, guys, I will say this again. Try to stay away from that coil ones. Because then you're going to say, oh, shit, I don't know when to divide. So all what I did, I take this transpose. What is my kVA? What is my voltage? 11,000. What is my root? Root 3, right? 39.4 amps over here. Right, guys, what is this current? Now, we know it's going to be way more. It is not going to be 27.5 times more. It's the coil current is 27.5 points more. So all I'm just going to say is the same old thing. Put it in, and I got an answer of 626. 625, 626. Now, take your calculators. Say 626 divided by the ratio of 27.5. So say again, 626 divided by 27.5. How much you get? Okay, right. That's your coil current. Now multiply that with root 3. Get 39. Now, guys, if you got faith in yourself, this is three-phase transformers. It is not getting harder. It's getting easier.
So that's the extent of it.
Now, why do people don't want to do this? I don't know. So if you know how to work at primary voltage, secondary voltage, primary current, secondary current, voila. But important, there's about 3 or 4 examples I gave you. You're going to practice it. Right. Is there any questions on transformers?